From the massive studios in Raleigh, North Carolina, this is the Cloudcast with Aaron Delp and Brian Gracely, presented by A Cloud Guru, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive studios here in Raleigh, North Carolina. One of the things that we're always trying to do as we introduce new topics and introduce new areas that we may cover in the show is not just have one show about a topic, but whenever possible, really dig into it in a little more depth. And, you know, if you've been listening throughout the year, or you've been a long-time listener, you know that we've been focusing a little more this year on topics around machine learning, around AI. For us, it's a newer topic, so we're trying to bring in different viewpoints, both from a vendor perspective, but also from an experience perspective. And so this week we're very, very excited. We're very excited to welcome Chao Han, who is Vice President and Head of R&D at Lucidworks, and a company here in the Raleigh area we're always excited to talk about. But Chao, welcome to the show.
Thanks, Brian. It's an honor to join you.
So first off, we're gonna get a chance to talk about machine learning and AI. It's really your background, what you do research in, what you're building. But before we get into that, tell us a little bit about your background, prior to Lucidworks, or really just the breadth of your background in terms of skills and knowledge.
Sure. I'm a data scientist with over 10 years of analytical experience in both academia and industry. I got a PhD in statistics back in 2012. After graduation, I first worked at JPMorgan Chase, the R&D department, supporting different line of business projects in areas such as the bank transaction tax mining, the social media sentiment analysis, fraud detection, default prediction, and some target marketing stuff. And after Chase, I joined SAS to help develop a new platform called SAS Model Implementation Platform, which is an in-memory analytic engine that enables faster model implementation on a graded network. And currently, I lead the R&D team at Lucidworks, and Lucidworks is an enterprise search engine company. So we help the customer kind of improve their search experience through a product called Fusion AI, with functionalities such as recommender, query analytics, NLP, automatic document clustering, and question answering system.
Excellent set of background, not only in sort of the mathematics and the technology that's behind that, but also it's great to have a set of background that's not just in the software industry, but in the finance industry. So having an understanding of kind of the complexities of industries is excellent. So you've got teams of people that are working on this. You're building technologies. That's one of the questions that always comes up when we talk to different people is, what are some of the basics that companies do when they're hiring data scientists? What do you look for in terms of the skill set, or sometimes how do you help? How do companies think about sort of shifting from, well, we have some business analysts to, we need a different skill set or a different set of, kind of platforms to help us be successful in, machine learning and AI, as opposed to just sort of what they might have thought of as statistical analysis?
Great question. So as for hiring, because I involved in hiring in the past jobs and then lead a team now in the current job, I think there are four basic features most data science hiring manager are looking for. The first one is the programming skills. Since we have to put the models into production to make it useful, so you not only need to know the algorithm, you have to code it up. And the second feature is the understanding of the backend machine learning algorithms, such as the pros and cons of different methods. So rather than calling the Python API, you better know when to use and when not to use certain methods. And the third one is the communication skills. Since data science is very interdisciplinary, and data scientists have to be able to communicate with business users, ask the right questions, and explain the models. So both written and oral communication skills is pretty essential. And last, I think the most important one is the problem-solving skills. It's basically the capability to connect the business problem with machine learning methods. And usually this skill require working experience before. And as a research team, in addition to those skills, I also prefer candidates who is innovative, who invent new algorithm from scratch before, since a lot of times an existing algorithm may not be a good fit for certain problems. And some other good qualities also includes the ability to pay attention to details, fast learning capabilities, and logical thinking. To be honest, it's pretty rare to find such candidates who have all the above features. But it is our data scientist development goal at Lucidworks to help the employee to be strong in all these aspects. As for the question about shifting from statistics to AI and machine learning skill set, to be honest, I don't think there's big shift since statistics, machine learning, and AI are all actually very similar sets of methods. For example, many models in machine learning is based on regression, but regression is basically statistical 101. And also, most of the techniques in deep learning is inherited from traditional machine learning methods. For example, the idea of convolution, pooling, dropout, batch norm, and even ReLU. ReLU is relatively new, but it's basically just hinge function. And none of them are totally new. So I think the main difference here is the machine learning and AI rely on the advances of hardware and programming techniques such as the GPU, in-memory computing, and stochastic gradient descent, which make analyzing big data possible. But traditional statistical methods is actually very effective with analyzing data sets using direct formula derivations. If we're able to put a very big data all in memory and able to compute matrix inversion at once, statistics can be even faster. But since we can only analyze big data piece by piece, so we have to rely on computer kind of greedily search for the optimized parameters. But I've seen people with skill sets, for example, I got the PhD in statistics, and I transited from statistician by programming a lot and to machine learning. And besides, my PhD topics is mainly related to machine learning. So it's possible to transfer from one background to the other because all these methods are connected.
Yeah, that makes sense. Now, let me focus on Lucidworks more specifically for just a second. So Lucidworks specializes in enterprise search, but you're also extremely active and primary sponsors of multiple Apache projects. Tell us a little bit about how these technologies both fit into the enterprise today, and who are some of the newer AI and ML frameworks being built in conjunction with these Apache projects?
Yeah, sure. Let me introduce a little bit what kind of projects and problem we solve. So Lucidworks delivers AI-driven enterprise search to Fortune 2000 companies, both on-premise and in the cloud. So examples of search problem we help our customer solve, including search the enterprise intranets, and also product search from an e-commerce website, or general information search, such as search on Reddit. And Reddit is actually supported by the Lucidworks Fusion platform now in their search. So our flagship platform is, again, called Fusion. So it allows companies to incorporate intelligent search features such as product recommendations, spell checking, auto-suggest, and query writing into their applications without having to build their own system from scratch, and then give them the feeling like a similar the search experience by Amazon and Google. Since we focus on machine learning features in the last few years and also enable many natural language processing capabilities, so our applications are not just limited to search. For example, we have a suite of e-discovery platform, such as an algorithm such as document clustering, anomaly detection, topic trend analysis, and synonym discovery. And all those can serve the needs beyond search department of a company. And our ultimate company goal is to solve the last mile problem in AI. That is to make the complex data science available to end users directly without requiring user to have any background in data science. As for the AI framework, in addition to Apache Solr, we also heavily rely on Apache Spark in the backend to perform big data processing and train and implement machine learning models in production. As you can see in the last few years, the company start to transition from Hadoop system to Spark. Before Spark, we only kind of mostly use Java with Hadoop to analyze big data. And running machine learning models is actually hard with Hadoop since it's not in memory processing. And nowadays, with Spark, you can program in Scala, in Java, Python, or even R in the Spark environment. And you can easily analyze the big data. And in our Fusion platform, customer can also run Python packages of their choice in our customer jobs panel. And very excitingly, we will enable deep learning packages such as TensorFlow very soon.
Very cool. Very cool. So, we were talking just a second ago, you were kind of talking about the skills of data scientists. And one of them, you highlighted was interpersonal skills because it's an interdisciplinary area. Can you talk a little bit about, how does the translation work between typical lines of business who, want to say things like, well, we need to find a needle in a haystack. How do we figure out, where our next customer's coming from? Things that sort of the language that they speak on a regular basis. How do you translate that into what data scientists need to understand? And then, the things that they're interested in, statistics wise, math wise, programming wise, like walk us through a little bit of that sort of translation effort that has to go on between the way lines of business talk and the way that data scientists have to interpret that and turn that into things that, like you said, can ultimately be, I don't have to be a data scientist to get outputs from the data that's collected.
Yeah, sure. So I think in order to speak the right language and then efficiently understand the problem, it needs kind of years of data science experience. Because a lot of times customer asks for one thing, but actually he or she do not really mean that. For example, a lot of customers say, I want a classification, but they don't have label in their data. Then what we can do is actually run unsupervised learning methods first to automatically generate label for them and use that label to do the classification. So I think the process is look at their data and then ask what's your pain points as a starting point. For example, in plain language, what kind of search problem you see? Can you give me some example, you didn't find relevant stuff from your search results? And then given the problem statement and then combined with their data, we will start the analysis and start to investigate what under the hood things happen there to lead to that kind of problem. And then starting from there, we will connect our out-of-box tools to help solve different kind of problems for them.
So let me kind of also then take that one step further and ask, what are some of the things from a research standpoint you've recently been focused on? Give us some kind of examples of some ways customers are using this today, and to kind of really make this easier, like you were saying earlier, to kind of do that last mile.
Yeah, sure. I'm glad you asked this question because a key differentiator of Fusion to other vendors is that we're providing operational AI that non-data scientists can easily adopt and use to solve their own problem. So you may already see many automatic model building vendors on the market to provide a bunch of tool sets to easily run things like logistic regression or decision trees. But for a non-data scientist, he or she may not thoroughly understand what regression is and how to connect regression with their problem at hand. So at Lucidworks, we're making Fusion a solution, or it's kind of make it a solution-oriented software rather than just a toolbox. Specifically, we'll provide end-to-end solution from data capturing until the end for result interpretation. For example, at the beginning, we automatically capture user online behavior, such as what people search, what they click on, whether they add certain things to carts or purchase. And the next step is like those kind of information we automatically ingest it and store in Solr. And we automatically shape the data in the format that machine learning model can consume. And in the backend, we use Spark to run machine learning models, such as recommendation, learning to rank, query intent, and spell checking. And at last, present those results in our UI dashboard and directly connect to a pipeline to help improve search relevancy at query time. And the whole process is very streamlined and easy to set up, which makes AI more operational rather than waiting for months or even years to see fruit from a data science project. And you can see big impact in a very short period of time using Fusion. And currently, we are developing more methods to enable data exploration and user interaction directly through visualization, so that both data scientists and non-data scientists can use our platform to perform data discovery easily. And then an issue I do observe, especially for the current new graduates, is like a lot of people focus on Kaggle computations. Kaggle, to be honest, Kaggle is really good. It's like open, everybody can practice their data science skills. But the problem here is like, I feel Kaggle is still far from reality. So in reality, it's like the data you get have a lot of noise. You don't have a label. And then you have to come up with methods for non-data science easy to use. But in Kaggle, there's a tons of manually label thing, and then the data is formatted in the training and validation and testing format already for you so that you can directly run stuff. So it's better to have some work experience, work with the real data from customer. And that's a suggestion there.
And I'm glad you brought that up, actually. What would be some of your kind of recommendations for folks that are interested in this space and just kind of want to get started? We have a lot of listeners who may not be necessarily practitioners in this space, but but are very interested in this space.
Mm-hmm. So it depends on what's the starting point. If you're a statistician already, then you may need gain more programming experience. If you're a computer science background already, it's better to read some basic statistics books so that to fill in the gap. And then a big new trend here, especially on the involving interest part, I see two major trends happening. For example, one trend is with the healthy development of the open source community, more and more analytics shift from traditional analytics tools to open source languages such as Python, Scala, and R. And then I usually recommend learning multiple languages because there's always methods that exist in one package language but does not exist in another. And different language has their own strengths. And on the methodology side, apparently a new trend is the fast growth deep learning community. And then you can see the new deep learning architecture come out every month. So interestingly, a graduate student can easily build a deep learning model that beats state of art, which was traditionally built by a big team before. So I see a lot of people play with the deep learning stuff, which is pretty exciting. But one problem here is like if you just know how to run a deep learning model, basically like grab an online notebook and then run it, but don't know the connection between the history methods, then you may lose the points like where different methods from and how to further improvement. And then also there's some concerns about the deep learning usage, the large scale application in the industry, because even the inventor of the deep learning algorithm still lacking the knowledge of the underlying math of why and how deep learning works. Why does it work so well? And then, so it has to be using different tricks together to prevent overfitting and also burn a lot of GPU powers to build model from scratch. And then those are the factors make deep learning production and large-scale usage pretty hard. So that's why in our R&D practice at Lucidworks, I always design the research experiments to compare traditional methods versus deep learning methods. Since if we have to run a model on a GPU farm for a week to increase prediction accuracy by less than 2%, then combined with each customer's cost concerns, we can provide either traditional solution or deep learning solution. So if you are interested in machine learning, I think I know the trend now is deep learning. It's pretty fun to play with it, but it's also beneficial to learn about the traditional methods.
Very, very cool. A lot of stuff we covered today. I think, for a lot of people, they're listening to this. They're hearing a lot of new things. They're hearing about Kaggle and Kaggle competitions for data science, Python and R and things that maybe we don't always cover in sort of all of our cloud computing stuff. So we will definitely get links to those things in our show notes. Chao, thank you so much for kind of all the perspective on it, not only the technology that's going into this, but also, the perspective on the types of skills that people in your domain are using to be successful, how to communicate between the technology groups and the business groups. So thank you so much for the time today. Thank you for kind of, putting up with a lot of our basic questions, but giving us a lot of very rich information that people can go dig into. So if anybody wants to either reach out to you or learn more about Lucidworks or anything like that, what are some ways that they might be able to maybe follow up on some things?
You can find my name on LinkedIn, and I'm pretty open. Like anybody add me, I would just usually accept.
Okay, very, very cool. Well, listen, we will get all that stuff in the show notes, and folks, hopefully there was some information here. If this area is new to you, definitely take a look at it. As always, our good friends over at A Cloud Guru have some big data learning courses that you can take, and discounts are available on the website and everything. So for Aaron, welcome back to the show. Good to talk to you again. And for Chao, folks, thanks for listening this week. And as always, we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more podcasts, show notes, and everything social media. And visit acloud.guru for all your cloud training needs.